Good morning, everyone. Um, in today's lecture, we are going to discuss consumer preferences with single and multiple goods. In our previous lecture, we look at the concept of cardinal utility, marginal utility, and total utility. We try to also obtain the point of the saturation point. That is the point at which um, the marginal utility is equals to 0. We also try to superimpose um, the total utility and marginal utility on a particular graph. And we also look at the concept of diminishing marginal utility. That is, at some particular point, the consumer gets less and less satisfaction as it consumes more of the good. So in today's lecture, we're looking at consumer preferences with single and multiple goods. We're going to begin this discussion with 4 basic assumptions of consumer preferences. So let's go ahead and get started. Um, Here we look at various bundles of the goods consumed. Now, we are assuming here that the consumer consumes only 2 commodities, that is clothing as well as food. Now, we see that the consumer prefers bundle C to bundle B because he gets more of one good, which is food, which is clothing, and the same amount of food. He gets more of clothing than in bundle B. So in bundle B, the individual gets 80 units of food and 10 units of clothing. But at bundle C, the consumer gets 80 units of food and 30 units of clothing. So bundle C is preferred to bundle B because with bundle C, the consumer gets more of one good and less of the other, which is clothing. So we are going to also use these concepts to look at all the 4 basic assumptions of consumer preferences. So the first assumption states that preferences are complete. They are complete in the sense that a rational consumer is able to compare 2 or more bundles of goods. Now, as we saw in the previous slide, we see that the consumer is able to compare 2 bundles of goods, that is C and B. He can also compare 2 other bundles of goods, C and A, depending on the amount of goods that are in each particular basket or bundle. Now let's consider 2 bundles of goods in the diagram, C and B. Now, if the consumer prefers C to B, that is to say, C is preferred to be, strictly preferred to be. So that sign, greater than sign, means strictly preferred. C is strictly preferred to B. The consumer also prefers B to C. That is, B is also strictly preferred to C. Or is indifferent between the two bundles C, that is, C is indifferent to B. So that sign there means indifferent. So that is, the consumer is as well off as consuming either C or B. So if the consumer decides to select or choose C or B, it gets the same amount of satisfaction, so much that it's indifferent between the two bundles. So that is the meaning of that C is indifferent to B. So C is greater than B because the consumer strictly prefers C to B because it derives more satisfaction. In other words, it's better off having C than having B. So that's the meaning. So preferences are complete if this is the case. If the consumer is indifferent between C and B, it means that he or she is equally happy with bundle C and B. So if I am indifferent between those two bundles of goods, it means if I have B, I am happy, and if I have C, I'm also happy. So I'm equally happy if I have any of those two bundles, regardless of which type of bundle that I get. Any one of those two bundles gives me greater satisfaction or gives me happiness. So that's the meaning of saying that preferences are complete. So if C is preferred to B and then B is preferred to C, then the consumer can also be indifferent between those two. That is C and B. In other words, is equally happy having any of those two bundles. Now, the next assumption of consumer preferences that we're going to look at later on is that preferences are transitive. So this implies that the consumer is consistent when making choice decisions between bundles of goods. So whenever it wants to make decisions between bundles of goods, let's say bundle C, B, and A, it makes its decision consistently. It makes its decision consistently. Now consider three bundles of goods, C, B, and I. Now, here I'm referring to the previous diagram, the previous slide, the diagram on the previous slide. So let's consider bundles of goods C, B, and I. If a rational consumer prefers C to B and then prefers B to I, it implies that she prefers C to I. So this is the transitivity of consumer preferences. So it requires that if C is preferred to B and B is preferred to I, then it follows that C is preferred to I. So this is the transitivity assumption of consumer preferences. Now, move on to the other assumption, which is non-satiation or monotonicity. So we see that some utility functions are monotonic. In other words, a consumer prefers more of a good to less. More of a good to less. More is better. But is this assumption realistic? Does it hold in all cases? We are going to take a look at shortly that this particular assumption collapses or it breaks down. That a consumer may not prefer more, or more could not be even better. More of a good would not make the consumer better off. So we are going to take a look at this one. But for simplicity, we are going to remain with this particular assumption, the assumption of non-satiation or monotonicity. That is to say, the consumer prefers more of a good to less of it. So more is better. So that is the assumption. So it means that preferences are monotonic. If more is better, then a consumer is better off having bundle C to bundle B. Because bundle C contains the same amount of food, but more clothing than bundle B. So you see bundle C has 80 units of food and 30 units of clothing, and then bundle B has 80 units of food and then 10 units of clothing. So the consumer is happier having bundle C than bundle B. So it prefers bundle C to bundle B because is happier having bundle C because it contains more of one particular group and less of the other. So if we go according to this assumption that more is better, then we expect the consumer to prefer bundle C relative to bundle B. Now, let's move on to the next assumption, which is convexity. Consumers prefers a mixture of goods to extremes. Now, let's say, for example, in the previous assumption, we noticed that if the consumer decides to have bundle B, that is, let's say, 80 units of food and then 10 units of clothing, right? And then he also decides to have bundle C, 80 units of food and then 30 units of clothing. So he's trying to compare between those two bundles. Which one is he going to choose? Now, so what the convexity assumption is saying here is that if he takes an average of those two, that is average of, let's say, maybe 0.25 of C plus 0.75 of B. So if he takes those average, is better off than just selecting one particular bundle, one of each of those ones, either C or B. So instead of the consumer choosing bundle B or bundle C, so he can just take an average of those two. That is to say, maybe half D plus maybe half B plus half C. So if he takes that one, that particular bundle is better off than just choosing one of them. So that is the meaning of convexity. So consumer prefers a mixture of goods to extremes. Individuals like variety, and they hate having none of a good. So let's take, for example, we have a case where bundle B, the consumer consumes 40 units of food and then 30 units of clothing. And then for bundle J, the consumer consumes 0 units of food and then 20 units of clothing. So we notice that if the consumer decides to take the average of those two bundles, let's say AD plus 1 minus AD, where A is less than 1, so it could be 0.2, and then 1 minus A is 0.8. So if he decides to take that particular average, he is better off having that average than having either J or D. So he prefers having that particular combination, the average of D and J, instead of just D or J. So that is what the convexity assumption is trying to bring out. Now, let's move on to the concept of utility functions. Now, a utility function is just a mathematical expression that shows a measure of the level of satisfaction received from the consumption of a good or a pair of goods. Now, let's take, for example, we have a utility function u of x equals to 3x. Now, this is the function for a single good. Now, show that this function satisfies the non-satiation or transitivity assumption of consumer preferences. Now, in order to prove for non-satiation here, what we need to do is to just take the derivative of the utility function with respect to x. And so the u of x, the x, is just the marginal utility of x, which should be positive. For non-satiation assumption to hold, that is more or better to hold, the marginal utility has to be positive at all times. It has to be positive. But is that the case? No, it is not sometimes the case. Marginal utility can be negative, as we are going to prove shortly. So, but for the non-satiation assumption to hold, the marginal utility must be positive. So in this particular case, the marginal utility of good x is 3, because the derivative of u of x with respect to x is just 3. Since 3 is a positive value, then we say the non-satiation assumption holds. In other words, the utility function is monotonic. In other words, it is a monotonic preference transformation of the consumer preferences. It is a monotonic transformation of the consumer preferences. So in this particular case, the utility function is monotonic. It is monotonic in the sense that the derivative of the utility function with respect to x is equals to 3. In other words, it is positive. It's a positive value. So the non-satiation assumption, we will see this particular case. So when we say non-satiation, it means the consumer is never satisfied. But is that true? Is that true? In some cases, it is true. In some cases, it is not. So in real life, it is not. When you get more of some good, sometimes you feel that you have reached your saturation point and that you can no longer want to have that particular good. So your marginal utility, that is the utility derived from an extra unit of the good consumed, declines as you consume more and more. So what the non-satiation assumption here is telling us is that as you consume more and more, you want more and more. So that means you are never satisfied. You are never satisfied. So that is what the non-satiation assumption is about consumer preferences. Now, to prove for transitivity, what we need to do is to consider 3 bundles. Let's say A, 5 of good X, B, 4 of good X, and then C, 3 of good X, right? So according to the transitivity assumption, if U of X, if U of X, that is, if U of A is greater than U of B, that is the consumer prefers A to B, and U of B is greater than U of C, that is the consumer prefers B to C, then it follows that U of A is greater than U of C. Or in other words, U of A is greater than U of C, that is the consumer prefers A to C. Now, plugging for X into the utility function gives what? U of A is what? 3 times 5, because X is 5, when 5 units of the good is consumed. So that is 15. And then U of B is what? 3 times 4, which is what? 12. And then U of C is what? 3 times 3, which is 9. So since U of A is greater than U of B and U of B is greater than U of C, then it follows that U of A is greater than U of C. So this shows that the consumer is consistent in making choices. Preferences are transitive. So you have to look at these ones for your test, for your homework, for your assignment. Please go over these ones. Make sure you understand them, what they mean, what transitivity means. Make sure you understand what non-satiation means. Make sure you know what convexity means at the same time. You also need to know the other assumptions of consumer preferences. So make sure you know all of them. Make sure you're able to do everything. Everything. So now let's look at the case where the assumption of non-satiation does not hold. Now, if we look at the total and marginal utility function here, graph, we notice that the marginal utility, which is the slope of the total utility function, decreases. The marginal utility decreases as we consume more and more of the good. So at point B, the marginal utility there is positive. But when we move to point D, which is the saturation point, the marginal utility drops to 0. So at point B, so beyond point D, the marginal utility is negative. So this means that the consumer is satiated at point D. That is, it becomes satisfied. The consumer is well off, is satisfied at point B, point D. So beyond that particular point, if you decide to give him more of good X, it's never going to appreciate that because it derives less and less satisfaction from the consumption of that additional good. So from the consumption of that additional unit of the good. So it derives less and less satisfaction. So at that point, D is the saturation point. So this means that the assumption of non-satiation does not hold in this particular case. Because if more is better, then the consumer will continue to consume even though he has reached his saturation point. It will continue to consume more. But according to this schedule here, we notice that after point D, the consumer would not like any more of good X because its marginal utility is declining, is negative. So because the marginal utility is declining, it's moving to the negative axis, we say that the assumption of non-satiation, more of a good is better to less of a good, does not hold in this particular regard. So if we notice here, we see that the total utility curve and the marginal utility curve are not on the same graph. Why is that so? Can anybody tell me why this is so? Why don't we have the marginal utility as well as the total utility on one particular graph, as like the cost curves, or maybe like the marginal product, total or something? Why don't we have them on the same graph? It is simple. The answer to this question is simple. The reason is that we do not have the same argument on the vertical axis. We do not have the same argument on the vertical axis. Even though the horizontal axis, we have the same argument, quantity of good X, quantity of good X. But for the marginal utility function, we have MUX on the vertical axis, and then for the totality function, we have U of X, right? So, because we have those two different arguments for each of those graphs or those functions, we can't graph them on the same graph. We can't put them on the same graph. We can't plot them on the same graph. So that is the reason why we can't have the marginal utility and the total utility function on one particular graph. So if you look at the point where the marginal utility diminishes, right? After point what? Maybe point D. You see the marginal utility moving down to zero, to negative, right? So the consumer reaches a saturation point at point D. So you see point D corresponds to D prime. So D prime there is the marginal utility, which is 0. And then if you look at the line QR, and then this, it measures the slope of the total utility function at point B. So at point B, the marginal utility corresponding to that is equals to B prime on the marginal utility curve. Then point D corresponds to point D prime on the marginal utility curve. So we notice that at point D, the total utility reaches its maximum point. So at that particular point, the derivative of the total utility function with respect to the quantity is equals to 0. So that corresponds to point D prime, which is 0. So we see that the marginal utility function has a 0 value, and then the total utility is, it reaches a maximum point. So it corresponds to the marginal utility. That is the utility, a additional utility derived from the consumption of an extra unit of the good. So it is equals to 0. So beyond that point, the consumer would not like to have any amount of the good. So the assumption of non-satiation here does not hold. This is where the assumption collapses. It does not hold here. So you need to know this one. It does not hold in this particular regard. So you remember all those 4 assumptions that we stated on the previous slides. One of those assumptions does not hold in this case, because when the consumer reaches a point of saturation, in other words, it is satiated, it is satisfied, it can no longer want to have more of the good. If you decide to give him anyone, it will not take it because his satisfaction declines. Now take, for example, you are drinking water. You drink the first cup of cold water, you may want more. You drink the second cup of cold water, your satisfaction continues to decline. Your hunger for water declines. Now let's move on to the third. It continues to decline. Maybe after the 4th cup, maybe you may not want to have any more. Even if somebody offer you any other cup for free, you don't want that one because you have reached your saturation point. So you see how the assumption of non-satiation or monotonicity collapses. So it is not in all cases that utility function is monotonic or a monotonic transformation of consumer preferences. So in this particular case, the consumer is satiated at point D. So it can no longer accept any additional amount of the good because it derives less and less satisfaction as it takes an additional unit. So this is the point where the assumption of non-satiation collapses. So it is not always more of a good is better. Sometimes less of a good is better. It is better when the consumer reaches a satiation point. In other words, a saturation point. It can no longer accept any amount of the good.